Hi, welcome to FODIC. In this video, we will discuss the wastewater treatment plant, its unit processes, and the method of treatments used for the removal of pollutants. The term wastewater includes liquid waste and waste transported in water from household and industries. It may contain high concentration of organic and inorganic pollutants, pathogens, microorganisms, and toxic chemicals. This ensures the treated water meets regularity standards that protect public health and environment. Wastewater can be treated using three main types of processes, depending on the type of pollutants and the desired level of purification. In this video, we will discuss only common type of pollutant and its removal process by unit processes. The process begins with the bar screen, which acts as the first line of defense in the treatment plant. It consists of metal bars placed across the flow channel to trap and remove large floating materials such as plastics, rags, and wooden pieces. This simple but essential step protects pump, valves, downstream equipment from damage and ensures a smooth flow of wastewater throughout the system. Wastewater flows into the grid chamber. The main purpose of this unit is to remove the heavy inorganic materials like sand, gravel, and sludge that enter the sewer from surface runoff or household drains. The velocity of the wastewater is carefully controlled so that these heavier particles settle to the bottom, while lighter organic matter remains in suspension. Common types of grid chambers include horizontal flow, aerated flow, and vortex types. After grid removal, the wastewater enters the oil and grease trap. This unit separates floatable organic substances such as oil, fats, and grease that typically originate from kitchen foods, industries, and laundries. Because these materials are lighter than water, they rise to the surface, forming a layer that is skimmed off mechanically using scrapers or rotating paddles. The partially cleaned water then moves into the coagulation and flocculation unit, also known as flash mixer. In the coagulation step, chemical coagulants like ferric chloride or ferrous sulfate, commonly known as alum, or some polymer like polyammonium chloride, are rapidly mixed into the water. These chemicals neutralize the surface charges on fine colloidal particles, causing them to destabilize and close together. In the flocculation stage, gentle mixing allows these particles to form larger, heavier clusters called flocks. To enhance the process, flocculants or polymers may also be added. As the flocks cross, they settle down under gravity, while clarified water moves upward, ready for the sedimentation in the next unit. The next stage is the primary clarifier, where gravity settling takes place. The water enters a calm tank where heavier solids, including sand and flocculate particles, settle at the bottom as sludge, while oils and scum float to the surface. Mechanical scrapers continuously collect the settled sludge and surface skimmers remove the floating materials. From here, the clarified water enters the aeration tank, the heart of activated sludge process. In this unit, microorganisms break down dissolved and colloidal organic matter in the presence of oxygen, supplied through diffuser or mechanical aerators. The bacteria consume the organic pollutants and convert them into a stable end products like carbon dioxide and water and new microbial cells. Continuous aeration and mixing ensure efficient contact between microbes and wastewater, achieving significant reductions in BOD and COD levels. The mixed liquor from the aeration tank then flows to the secondary clarifier, where the biological solids settle under gravity. Clear treated water overflows from the top through collection weirs, while the settled biomass forms a sludge layer at the bottom. These clarifiers perform two key functions: clarifying the effluent and thickening the biological sludge. A portion of this settled sludge, known as return activated sludge, is pumped back to the aeration tank through the sludge return line to maintain a balanced population of activated microorganisms. The excess portion, known as waste activated sludge, is directly to sludge handling facilities for further processing. These recycling ensures stable biological activity and consistent treatment efficiency. But before that, the sludge collected from the primary clarifier and secondary clarifier is directed to the gravity thickener. This unit reduces the volume of sludge by allowing solids to settle and compact under gravity, while water is decanted from the top. After biological treatment, the effluent then passes through the filtration unit, which serves as the final polishing step. The water flows through layers of sand, gravel, and activated carbon media that remove remaining suspended solids, turbidity, color, and odor of effluent water. Activated carbon also absorbs trace organic compounds, leaving the water clear, odor-free, and suitable for non-potable reuse, and safe enough to release to the environment. After biological treatment, the clarified effluent undergoes ozonation or chlorination for disinfection. Powerful oxidizing agents like ozone or chlorine are introduced to destroy pathogenic microorganisms such as bacteria, virus, and other membranes and enzymes. This process ensures the treated water is microbiologically safe before its final use for discharge. Through this series of physical, chemical, and biological processes, the wastewater treatment plant transforms polluted water into a clean, environmentally safe effluent. That's all from today's video. If you like this video, do hit a like, subscribe, and share tab. Thanks for watching. Take care and goodbye.